Today we will do interesting topic which is simply supported beam subjected to UDL. We will determine the shear force diagram and bending moment diagram for it. Before that we have to determine the reaction. So how we will determine the reaction? See, UDL load is subjected here. It is a simply supported beam supported at A end, supported at B end. The total length is L. I have make a section X. Okay, for section we will discuss it shear force and bending moment. Let's determine the reaction first. So let's take moment about B equal to 0. So moment about B, that means what? See, here the reaction will be what? R suffix A, and here the reaction will be R suffix B. So R suffix A, this one, into L distance Y, we are taking the moment about B. So this will be positive because I am considering this moment positive and this moment negative. So, and minus this one is what? This W per unit length. So this will be what? Load will be what? W into L and into L by 2. This will be equal to 0. So if I solve it, R equal to, this one will be WL divided by 2. So this will be the reaction at R suffix A. This is WL divided by 2. Now for determining the R suffix B reaction, we can do same moment about A equal to 0, or more easy, you will be taking the summation of vertical force equal to 0. So what will be the vertical force? See, at downward R suffix A and R suffix B will be acting, and at upward this UDL load is acting. So R suffix A plus R suffix B, this one will be, this one from downward force I have taken positive, and upward force I will be taking negative. So this will be what? Upward force minus W into L, because load is W per unit length. So for the total length, this will be W into L, this one equal to 0. So from there R suffix B will be equal to what? WL minus R suffix A. Put the value of R suffix A. What is R suffix A? This is WL divided by 2, which I have determined here. So if you solve this, you will get WL by 2. So at R suffix B will be also WL by 2. Okay, now we have to find shear force for it. So for finding shear force for it, I have make a section XX. You can make this, you can consider this from any end. You can consider it from A end or from B end. I am considering it from A end. So shear force from end A. So let I determine the shear force by F. So F will be equal to what? Downward force is R suffix A. So R suffix A minus upward which force is acting, this UDL. So this will be how much? Up to the section X, this will be W into X. So W into X. So this is the shear force. Now put the R suffix A value. R suffix A value is which one? This is WL by 2. So put here WL by 2 minus W into X. Now you have to determine the shear force at X equal to 0 and at X equal to L. Put here the value of X 0. So you will get shear force F will be how much? WL by 2. This term will be 0. And if you put X equal to L, so shear force will be what? W into L minus WL by 2, this WL by 2 minus, at place of X I will be putting L, so it will be WL minus 2WL divided by 2. So it will be how much? Minus WL divided by 2. So this is the shear force at X equal to L and at X equal to 0. So at X equal to 0, what is the shear force? WL by 2. Let WL by 2 value be up to that much. And at X equal to L, what is the shear force value? It is minus WL by 2. Now I have to determine the shear force for any mid section. So for any mid section, let's take up to L by 2. For L by 2, again put here X equal to L by 2. You will get the shear force F equals to what? WL by 2. So put here WL by 2 minus, at place of X again I will be putting L by 2. So WL by 2 minus WL by 2 what? 0. So at X equal to L by 2, what is the shear force here? 0. So I will connect it with a straight line. Why I will connect with a straight line? Because this variation is linear variation. So this is shear force for simply supported beam subjected to UDL. This is positive shear force and this is negative shear force. Now let's determine bending moment for it. We have determined the shear force for bending moment. Similarly, we have consider the section XX from A end. So for this reaction, what will be the moment? R suffix A into this X distance, and so M equal to what? R suffix A into X. Now it will be positive or negative. For that we have to see the bending is sagging or it is hogging. Let's see. R suffix A, this force, the moment due to this force will try to bend the simply supported beam upward, that is sagging bending, so it will be positive. And UDL, for UDL load, what will be the moment here? This W into X into the CG, that is X by 2. So W into X into X by 2. Now what will be the sign here? This UDL will try to bend the beam downward, that means hogging bending, so it will be negative. So what is the bending moment here? Put the value of R suffix A. R suffix A value is how much? WL by 2. So put here WL by 2 into X minus WX square by 2. Now what is the variation here? This variation, see, this is X square. If I put the value of X, this will be also in the square. So this value will, this variation is cubic variation, because this equation is the equation like y equal to ax square. So at x equal to 0 and at x equal to L, if you put the value, you will find the moment. So put here at x equal to 0, you will get the moment. Moment will be what? This will be 0. At x equal to 0, moment will be 0, and at x equal to L, if you put the value of L here, and if you put the value of L here, then you will get the moment. They are also same value, so 0. At x equal to 0, moment is 0, and at x equal to L, the moment is 0. So I have to find the mid moment again. Let's find the mid moment at x equal to L by 2. For x equal to L by 2, moment will be what? See, WL by 2 into, in place of x, I will be putting here L by 2. In place of x, I will be putting here L by 2 minus WX square by 2. W by 2 into, in place of x, I will be putting here L by 2. So L by 2 whole square, that means what? L square divided by 4. If you solve this is how much? WL square by 4 minus WL square by 8. If you solve this, you will get the value WL square divided by 8. So at midpoint, this positive, I have got the positive moment here, so I will raise it upward. Let WL square by 8 value be up to that much, and the variation will be what? Cubic variation, so it will be like parabola, like cube, sorry, not parabola, like cube. So the maximum bending moment is at L by 2. Remember, maximum bending moment for simply supported beam is at L by 2, and the value of this moment is WL square by 8. By considering this moment, we will design this beam when we will design for RCC reinforced concrete. Okay, thank you. Please subscribe my channel and please like it so that I can give my best to all of you.